Chapter 4, Section 5, Writing a Function Rule. So copy down the following word problem. Carolyn has 420 CDs in her collection. Each month, she adds 12 more CDs to her collection. What function rule represents this situation? So let's first look at the variables. So each month, she adds more CDs to her collection. So we have the number of months that she's adding CDs and the total amount that's in her collection. Now, which one is independent and which one is dependent? Well, the total amount that's in her collection would depend on how many months she's been collecting for. So that means that months is going to be our independent, so our X, and the total amount in her collection would be our dependent, which is our Y, but in this case it's a function, so it's our f of x. So we're going to let f of x equal the total number of CDs, and we're going to let x equal the number of months. Well, there's a constant rate of change, 12 CDs per month, and you're starting with 420. It's a linear function. We've written equations, linear equations, from word problems before. This is no different. 12 CDs per month. The starting point was 420, and this equals the total amount of CDs, which is our f of x. So in this case, our b is 420 because that's what we start at. And our slope is 12 because it's increasing 12 CDs per month. Again, please copy down the word problem. An archery club charges an annual membership fee of $65 plus $2 per visit. Write a function rule for the total cost of belonging to the club if you make V visits, so they're telling you what variable to use, in a year. Then it asks, separate question, how much would it cost you to use the club 15 times in a year? So we're talking in just 1 year. Well, in just 1 year, there's a one-time fee of $65 and an additional $2 per visit. We're using V for the number of visits, so that's one of our variables. Our other variable is going to be the total cost. So the total cost depends on how many times you go. So we're going to let the function at V, because V is our independent variable, it's the number of visits. The function at V, or you could even write C of V, since we're talking about the cost, is going to be our total cost, and V is going to be our number of visits. Well, it's $2 per visit, and an additional $65, and that equals the total cost. Now, this last part of the question is asking, how much would it cost you to use the club 15 times in a year? 15 times means 15 visits. So it's saying, what is the function at 15? So we plug in 2 times 15 plus 65. That gives us 30 plus 65, which tells us that you could make 95 visits. Copy down this last word problem. So we're writing a function rule for the area of a rectangle whose length is 3 inches more than the width. They're asking, what is the area of the rectangle when its width is 7 inches? We see these questions a lot. So we're talking about writing a function rule for the area of a rectangle whose length is 3 inches more than the width. Well, if the length is 3 inches more than the width, that means the length is 3 plus W. The width is just W. And we're looking to find the area of the rectangle. So let's say, since the variable that we're working with is W, because we got L in terms of W as well, width is our independent variable, so our X are independent. And our dependent variable is going to be the area. So let's say A of W is going to represent area. So those are our let statements. Now, the function A of W, well, in order to find the area of a rectangle, we do base times height, or sometimes it's written as length times width. Here we're talking about length times width. So we're going to do the length, which is 3 plus W, times the width, which is just W. Now you can simplify this down, you don't have to, but by distributing the W, we get 3W plus W squared, which normally you write the highest power first, so W squared plus 3W. So we have our function. Now the last part is asking what is the area of the rectangle when its width is 7 inches. So it's asking when W is 7. So we plug in 7. So we're going to do 7 squared plus 3 times 7. We get 49 plus 21, which gives us 70 inches, and we're talking about area, so it's inches squared.